Hi everyone, we are going to continue working on polynomial sketching from the packet, the last lesson. If you need an extra copy of the packet, the substitute has them on the desk, you just have to ask for it. We're going to scroll down exactly to where we left off, which was example 2, where we have Patricia creates a cubic polynomial with a leading coefficient of 1. The zeros of the function are 2, 3, and -6. They want you to write an equation and then sketch the equation. So in order to write an equation, first of all, what's very important is you actually use what they tell you to use. They're saying use P of X, and if you don't use that, you will lose point. From there, they give you several zeros. Now, remember the zeros, we have X equals 2, X equals 3, X equals -6. But in order to write the function, probably should move this down a little bit, you need to have the factors. And the factors are the opposite values. So if your 0 is X equals 2, the factor is X minus 2. And if the 0 is X equals 3, the factor is X minus 3. And the last one, if you have X equals -6, the factor is X plus 6. They're all the opposite values. Now, keep in mind that this does state that it is a cubic polynomial, which means it is a degree 3. So that means you should have at most 3 different solutions. We have 1 solution, 2 solutions, 3 solutions right now. That's already a degree 3, meaning all of these happen 1 time each to get that total of 3. You do not need the exponents of 1. Now, what else they tell you is that you have a leading coefficient of 1, so there should be a 1 in front. However, do you need to write times 1 in front? No, it's assumed, so that's up to you whether you would like to write it or not. But now that you have the equation, you can do 2 things. You could just put it in your calculator and see how the graph goes, or you can graph it without the calculator, and that's very beneficial to know how to do that. So if you would like to graph it without the calculator, we'll box this in as an answer. But without the calculator, you have your x-intercepts. Now, your x-intercepts are x equals 2, multiplicity of 1. How do I know it's a multiplicity of 1? Each one happened 1 time each, right? Because you have a degree 3, that means if you have 3 different answers, they could only happen 1 times each. If something happened more than once, then you would have more than 3 answers. So they're all multiplicities of 1. And remember that a multiplicity of 1 is straight. Looks like my pen messed up. Is straight through. A multiplicity of 2 is a bounce. A multiplicity of 3 is a squiggle. So we have our intercepts. Probably should list them out. We have, let's say this is 2, this is 3, and I guess that makes this one about -6. You do have to draw out your x-intercepts. The next thing you want is your end behavior. So you want your degree and your LC. So leading coefficient. The degree is 3. That is an odd number. Odd number, remember that the O stands for opposite arrows. And then the LC is positive. I know it's 1, and 1 is a positive number. That means the right arrow goes up. A negative leading coefficient would mean the right arrow would go down. Now, if the right arrow goes up and they are opposite arrows, that means left arrow, if they're opposite, must go down. So we're going to start from down here. and we are going to end up here. Now, drawing this together, you're going to start from the bottom, and you need to cross through this x-intercept. There we go. I went straight through the x-intercept because my multiplicity was 1. Now, when you turn around, you do have to turn around because how am I going to go through -6 and then hit 2? So you only hit 2 by turning around, straight through, and then you turn around and go straight through 3. Now, what I did was one possible graph. There are many ways to actually do that. Another way would be, oh, can we pretend that I hit here and here? There we go. Faking it. My point is, as long as you satisfy the conditions, you could draw any graph within reason. What you cannot do, and what we frequently see, something like that, something that is a sideways squiggle, you always want to pass the vertical line test. That means if you draw a vertical line, you must hit it at least 1 point each. So don't draw on a side, make sure everything is nice up and down. Let's see, final touch for the graph. There we go. Make sure your graph has your x-intercepts labeled. Make sure that there are no hard edges. Make sure they're nice and round, and put arrows on it. So, in summary, when sketching, specifically polynomials, and a polynomial is like y equals x squared, or y equals 3x to the 5th minus 2x squared plus 5. That's a polynomial. X with an exponent. So when sketching polynomials, your graph needs the following things. You need your x-intercepts with the shape based on the multiplicities. So the straight through, bounce, or squiggles. You also need the direction your arrows point in, and that is based on the degree, whether you are even slash odd, and it's also based on the leading coefficient, whether you are positive or negative. And most importantly, please remember to always draw smooth, round curves. I can't tell you how many people draw something like this and they just connect the dots. You will lose points for that. So let's try another one, harder one. On the axis below, sketch a possible function where a, b, and c are positive. Okay, let's sketch the function of that equation. The first thing you are going to do is you are going to find your intercepts and your multiplicities. So your x-intercepts, you're going to set this equation equal to 0. Because remember, when you do a t-chart, you are equal to 0. And you're going to get x equals a. It happened one time. How do I know it happened one time? I only see x minus a once because there's an exponent of 1 up top. X equals b happened one time. X equals negative c happened one time. So all of these are straight through. Now, you don't have numbers, you do have letters, so if you would like, well, you just put them wherever you feel like. However, you do have to read the rest of the graph. So, for example, it does say A is greater than B. So let's make, I don't know, if B is 3, that means A must be like 5, because 5 is greater than 3. So if you were to put that on your x-axis, here's B, and here's A. And again, you could put A wherever you want. You could put A right here, as long as A is going to be greater than B. So I'm going to put my A over here to make sure it's different. And for example, this is like 2, and this is 5. Doesn't matter as long as A is greater. I'm also going to put C on the right-hand side since it is negative. Nah, I don't want it to be that far. There we go. Please don't be confused by this. I know they say C is positive. So like, for example, if you have x plus 3, and then you go to solve it, you're going to get x equals negative 3. If it's confusing you, just ignore the positive statement in the question. Anyway, it is also saying we have one more x-intercept, not x-intercept, y-intercept. And that y-intercept is at D. So notice how it's saying it is positive. Positive y's are up top. So I'm going to put positive here. Next thing, once you sketched out all your intercepts, you're going to find your degree and your LC, your leading coefficient. Now, your degree is the sum of the multiplicities. I have 1 plus 1 plus 1, that equals 3. That is odd. And the O in odd stands for opposite arrows. Don't know why I wrote my R's differently. And then your leading coefficient, do you see a negative in front of this equation? I don't. I see a 1 in front, and a 1 is positive. Positive means that the right, hey, I wrote my R's differently again. My right arrow is up, and therefore, if they are opposite, my left is down. This kind of looks a lot like the last one. You don't have to make these little arrow marks. I like to write them in, that way I remember what I'm doing. I'm going to come from the bottom. I'm going to go straight through C, but look, I have to touch D, turn around, come back, turn around, go through A. Now, this graph is appropriate, but there are many different graphs that you can draw through it. So you can do something that looks like, that's a bad option. I'm just trying to show you that the y-intercept, this guy right here, does not have to truly be the turning point or the relative maximum. It could be wherever you choose to sketch it. But a lot of people just choose to do this. And there we go. If you would like, and probably to be more proper, you could put P of X next to it to label your graph. Naming and labeling your graph is only required if you have 2 sketches on the same grid. This is only 1 sketch, so you don't have to label it here. Yeah. Trying another one. You have the zeros of a cubic polynomial are -4, 1, and 3. There's a relative maximum of the function at -1, 9. Construct a sketch of the function on the set of axes below. Okay, so your zeros. You have x equals -4, x equals 1, x equals 3. And the question is, what is the multiplicity of this? They actually tell you, because it says that it is a cubic. So your degree is 3. You have 3 answers. Your degree tells you have 3 total answers. So all of these answers have to happen 1 time each, or else we're going to go more than 3. For example, if they are all a multiplicity of 1, then 1 plus 1 plus 1 equals your degree of 3. But if you change one of these to a multiplicity of 2, well, all of a sudden your degree is going to be 4, and that's not a cubic polynomial. So they're all multiplicities of 1. And I'm going to go and I'm going to put them on. I have 1, 2, 3, and 1, 2, 3, 4. Your degree I don't know what happened. I blanked out there for a bit. Degree plus LC. Your degree is 3. That is odd. So you have opposite arrows. Now, if they do not tell you what your if they don't tell you what your leading coefficient is, then you get to decide. So you can decide whether you want to go and end upwards, which would be a positive leading coefficient, or you could decide if you want to go and end downwards, which would be a negative leading coefficient. By the way, I don't think I mentioned it. All of these, because they're multiplicity of 1, are straight through. Now, sometimes the questions do give you additional information to figure out whether you're going to have a positive and a negative leading coefficient. And in this particular case, that extra information is the coordinate that they give you. This coordinate, first of all, is a relative maximum. So let's put that coordinate right here. You don't actually, well, yeah, you should label it since they mark it down. But you need to draw this graph in such a way that you hit all of your x-intercepts and you hit that maximum. So watch what happens if, here are my x1s. Oop, how did that even happen? Oop. Okay. Da-da. That is not an x-intercept. I got to get rid of that. Here are my x-intercepts. This is what I'm trying to hit through. These 4 points. If you start from the top, how are you going to hit the maximum if this maximum is up here, but my graph takes place down here? What you can't do is do this. That looks nice, however, you did not draw a cubic function because both sides go up, which gives you an even degree. Also, you created, by turning around in the middle, you created an extra x-intercept, which is not allowed. If they're telling you you're a cubic, you must have 3 intercepts only. So the only way to go through all 4 points is to, you have to play with it, but it is to start at the bottom, come up, turn around, and then go back up. And I drew this so that this is the maximum because they said it's the maximum. If you did something that looks like this, then my maximum is no longer at -1,9. So please be super careful how you draw. They will take off points if you're doing something other than what they said to do. And see how at the maximum, it's hard to draw, but I'm still trying to make everything a rounded edge. You're not making just a straight diagonal line. Anyway, yeah, that works for that one. Okay, we have 2 more problems. On the axes below, sketch a possible function. All right, we got to find your x-intercepts. You have x plus a, x minus b equals 0. You make a t-chart. You get x equals -a, x equals b. Multiplicity is 1 for both of them because they have an exponent of 1. They happen 1 time each, which means you go straight through. I'm going to plot my x-intercepts. I have -a, I have positive b. Then I'm going to go and find my degree and my leading coefficient. My degree is when you add the multiplicities together. My degree is 2. 2 is an even number, which means if it's even, your arrows go in the same direction. By the way, do you have to write all of this each time? You should. You do have to show some form of work. Does it have to be like this specific and neat? No, but you do have to show where the x-intercepts are coming from and how you're figuring out the end behavior. Now, your leading coefficient, what's in front? I see a 1 in front. Actually, I see a 1, a 1, and a 1. So if I were to multiply all those together, my leading term is 1x squared. So my leading coefficient is positive 1. I don't care about the actual number though, just the fact that it's positive. Because the leading coefficient is positive, the right arrow goes up. That says arrow. And because they're even and they go the same way, that means the left arrow also goes up. So both my arrows go up. And guys, a degree 2 polynomial, it is a quadratic. So or a parabola, however you like to name it. All you're going to do, all you're going to do is reread the question really carefully to make sure if there's something missed. And I did miss something. It says you have a negative y-intercept of c. So I'm going to put that down, I don't know, here. Great. Now I'm going to connect the dots. I'm going to go straight through. I'm going to touch C and come back up. Doesn't look that pretty, but it does meet all the requirements. I made C my turning point. You don't have to. You can do something that looks like, oh, maybe no squiggles in between. Sorry. Oh, it's very hard to draw. Hey, that one's not bad. There we go. You go straight through, you touch your intercept of negative C, and we have arrows on everything to get full credit. If you would like, you could label it g of x. Great. Last one. These are all regions questions, by the way. And because they're regions questions, you can use tricks. If you don't know what's happening in your calculator, y equals x plus pick a number, 3. Pick another number, x minus 4. Graph it, you're going to see something like this. So you can fudge your way through it by plugging numbers into the equation. And then we have this guy. This one's tricky. It says sketch a graph of polynomial p given the criteria below. So it's giving us 3 zeros. We have x equals negative 5, x equals 1, x equals 4. I'm going to put that on there. Now, it's also telling you it only has zeros at these 3 values, so there are no other x-intercepts that you can account for. Figuring out what's happening here, I'm going to go with purple. As x goes to infinity, infinity is on the right-hand side. So this is saying, as you go to the right, p of x, the function, goes to negative infinity. Negative infinity is down. So on the right, you should be heading downwards. As x goes to negative infinity, negative values are on the left. So as you go to the left, p of x goes to negative infinity. So the function goes down. And I'm wondering if maybe you're figuring out the issue. And if you don't realize the issue, is that these are the same arrows. And same arrows indicate an even degree. But you have 3 solutions. This is or could be a multiplicity of 1, a multiplicity of 1, a multiplicity of 1, and that would make your degree 1 plus 1 plus 1, which would be odd. Well, it would be 3, which is an odd number. And odd numbers indicate opposite arrows. There's no other x-intercept. So what that means is that these multiplicities are not 1. Perhaps this guy is a multiplicity of 2. Perhaps this one is a multiplicity of 2. Perhaps this is a multiplicity of 1, this is a multiplicity of 3, and that's a multiplicity of 2. Because if you do that, then you still have an even degree if you add all these up. Now, they're not giving you enough information, so you actually get to choose what you want to do. Do I recommend this one? Not really. It's kind of hard. It would be straight through. A multiplicity of 3 is a squiggle, and then a multiplicity of 2 is a bounce. Who wants to actually draw that? So personally, I like this one. 1, 2, 1. Because if you have 1, 2, 1, the degree is 4, which is even. And even means the same arrows. And is the LC, in case they ask for it, is the LC positive or negative? Do they give you enough information? They actually do. If both of your arrows are going down, especially the right arrow is going down, that means your leading coefficient is negative. So what's happening here is I'm going straight, bounce, straight. So I'm going to go up. I'm going to come from the bottom, go up through -5, bounce at 1, and go straight through 4. If you were to draw it, come up from -5, go straight through, turn around to hit 1, bounce off of 1, and come back down to hit 4. You can make this graph more extreme or less extreme if you want. Here, more extreme. That's another one. That does not look pretty, but you know, gets the point across. Just make sure you have arrows on it. And again, this is only one possible answer. You could put your multiplicity anywhere. I hope this video helped. Don't forget, you do have the homework worksheet to do with this for the day 5 homework. Hopefully, it makes more sense now that you have this video.